In this video, we're going to graph 4 exponential functions. We just got through seeing how to graph exponential function with the base bigger than 1. So just to make sure you can see what this function is, this function is f of x is e to the x. This function is f of x is e to the negative x plus 1. This is f of x is 1/2 raised to the x minus 2. And this one is f of x is 5 raised to the x minus 2. All right, so how we begin this process, let's begin with e to the x. You must consider what is the base being raised to a power. So the base that's being raised to the power is e. And then you say, well, what is e? It is a number. That is 2.71 with some more decimals. So basically, 2.71 is greater than 1. So the basic shape of this graph will look like this. It will have an intercept at 0, 1. It will hug the x-axis, and it will be increasing like that. Just like it will have a horizontal asymptote at y equal to 0. So that's the basic graph of an exponential function with a base bigger than 1. So you say, hey, what would e to the x look like? It looks like that because the base is bigger than 1. So here's my intercept. Here is my horizontal asymptote. Y is 0. It will be an increasing function. It starts over here, and then it starts to increase like that. Okay, so the range is 0 to infinity. So you see you can only get positive numbers out of an exponential function unless they have a transformation or a reflection going on. And the domain is negative infinity to positive infinity. All right, let's go over here and graph e to the negative x plus 1. This negative is a reflection. When the negative is in there with the x, as opposed to being in front of it, like in front of it may be negative e to the x. That's in front of it. But when it's not in front of it, but it's in there with the x, this is a reflection across the y-axis. So we have two things going on here. This is reflect across the y-axis, and the plus 1 means shift up 1. This is up 1. This is a vertical transformation because it's outside away. So we have to reflect the basic graph, which is this right here, across the y. So if we reflect it across the y, then it's going to look like this, and it's going to be shifted up 1. So that means the whole graph gets shifted up 1. So if the horizontal asymptote is normally here, then that's going to get shifted up 1. So that means the intercept gets shifted up 1. And so if this is reflected across the y, then this up part's going to be over here, and the down part's going to be down here. So it's going to look like this. It's going to be down here close, and then it's going to go up like that. That's what the shift looks like. So the domain is still negative infinity to positive infinity, but the range got changed from positive 1 to infinity because of that shift. And now the horizontal asymptote is y is equal to 1. Okay, down here, f of x is equal to 5 raised to the x minus 2. The base 5 is bigger than 1. So the basic graph, 5 to the x without any transformation, will look like e to the x because the base is bigger than 1. So we have to say what's happening here. And what's happening here is it's got this minus 2, but the minus 2 is up here in the power. It's messing with the x, and that indicates a horizontal shifts, which are opposite than what they appear to be. So instead of left 2, we're going to go to the right 2. So we take this basic graph and we shift it to the right 2 places. So if this is the intercept, it's going to get shifted to the right 2 places. If the horizontal asymptote gets shifted to the right 2 places, it doesn't change. It's still right here. Y equals to 0. So that just means it's going to start its real increasing part a little further to the right. So that's basically what it looks like. The domain is still negative infinity to positive infinity, and the range is still 0 to infinity. Okay, over here, f of x is equal to 1/2 raised to the x minus 2. The base here is between 0 and 1. So this basic graph looks different. This is what it looks like. If you remember from the last video, This is what it's the decreasing exponential function. That's what that basic graph 1/2 to the x would look like. But it's this graph shifted down 2 places. So that means the horizontal asymptote, which would normally be here, gets shifted down 1, 2 places. So it falls down here. That's our new horizontal asymptote. The intercept is always 1, up 1. But this is a decreasing graph, and so it gets shifted this way, like this. And the reason this one looks like is a decreasing like this is because the base is between 0 and 1 instead of greater than 1. The domain is still negative infinity to positive infinity. The range, however, is -2 to infinity, and the horizontal asymptote is y equals to -2. So there are some different things that you might get with exponentials.